You, Patty, you have to.
I couldn't hear because I was
She
trying.
went to get water.
She went to get some water.
Oh, fine. And so I'm going to ask you questions. You're going to ask me questions. Didn't you like that yesterday? That it was open and it's informal. You have the formal paper. There's no reason for me to be ultra formal. And I publish a lot, and this is the first step in publishing. I give the talk, it serves as the outline for the paper, and I only have 200 papers, 250 papers, so it works. All right, so this is about adaptive neural nets accounted for by 4 instances of respondent conditioning. Now, none of you know about respondent conditioning, but so let me, first I'm going to review what stages are. There are only really 3 things in this talk. 1 are stages, 2 are the steps within a stage, and what else? There's one other.
Conditioning?
Oh, respondent conditioning. So the 3 ideas. And that violates all laws of papers. You're not supposed to have more than 1 idea in a paper. So I'm violating it. And so this will be like advanced graduate school. But I don't care because you guys chose to come to this university because it takes only the brighter students. You know that, right? It's highly, you get a good education here. All right. So a stage, I'm going to give you an example you'll all know. 3, at the primary stage, I'm going to go down. Primary stage is right here. You see there's 17 stages, so it's early, right? And the concrete stage is the next stage, and that's the lowest stage adult humans are found at who are not disabled. Okay, so here's 3 plus 5, and everybody knows it's 8. 5 plus 2 is 7. And that's primary stage. You learn that the first semester of school, right? Everybody, and you learn multiplication. 7 times 3 is 21. But guess what? If we give you this problem, 3 times 5 plus 2, you can't do it in the first grade. Do you remember when you learned it? You, Miss Water here. When did you learn that? Do you remember?
I think it was grade 4.
Correct, 3. 3rd grade, you learned that. And no matter how much training you give somebody when they're 5 years, 6 years, 7 years old, they can't get it. Okay? And so this is just like computer programming. You do a task analysis. You have to know how difficult the task is. And just like in computer programming, everything is sequenced. If you get the sequence wrong, you can't. If you don't have the correct input to the next step in the program just crashes. Right? So am I doing this in a language you guys understand? All right, so that's idea number 1. Everybody understand it perfectly. You understand this? Do you understand what I just said about the arithmetic?
Hi, yes.
Okay, I want to make sure everybody understands. Okay, that's idea number 1. And what we're going to talk about are only 3 stages, and they're very early. This is where you get conditioned reflexes, sensory motor. And I only know of a few animals at that stage. Clams, mussels. They don't learn from consequences. They only learn, I'm going to show you what way they learn. I'm going to give you a human example. On hearing a mother's voice, the infant turns their head in the direction and begins focusing. So you hear the voice, and that elicits the turning of the head. It's automatic. All right? Well, let me see if I go anywhere. So I'm going to talk about all the first 4 stages, and I'm going to show you how you build that in, the hardware. Anybody who wants to become an entrepreneur and make billions, pay attention, because I'll work with you. Because I don't do hardware, I do conceptual hardware. But it's easy to do. I'm going to show you how easy it is. And it will replace all the neural nets that now exist. Because if you do things in hardware, you know it's much faster than if you have to program them, right? Because you're working in binary. And binary is faster than anything, right? I don't know how I came up with this, but I came up with it. I can tell you the story. So, all life has activity. So if you look at a photoplankton or a zooplankton, you shine a bright light in them, too bright or too hot, they'll move away. That's called a tropism. Okay, you got that? Sensory motor, that's respondent conditioning. 2 stimuli are paired. The elicitation stimulus and the response to the elicitation. If I hit you in your knee swings up. That's a reflex, a respondent response. And if I ring a bell and I shoot food into your mouth, as Pavlov showed, you will soon salivate when you hear the bell. That's respondent conditioning. Very simple. Very easy to see that it goes on. It was discovered in, 1890. And Bechtra saw it but didn't understand it earlier. But it's the beginning of the revolution. When we understood conditioning, it was the beginning. So it's the most important kind of conditioning. If I shine a light and then blast some air into your eye, you'll blink. After a while, if I shine a light, you'll blink. You got it? 3 examples should do it for you. Now what this talk does is it's going to show you we can do the next kind of conditioning using the earlier one. And here are the 4 steps. And I'm going to go into them in great detail, so you don't have to learn them. But that's what happens. Let's say you have a cat in a box, and if the cat bangs the stick hanging from the ceiling, the box will open, and the cat will get out and be able to eat the food. learning from consequences. Okay? You all come here, you learn things. If you didn't learn, you would stop coming. Right? Is that clear? Consequence learning. So here are the 4 steps. Oh, I can see I didn't edit this slide very well. Oh, Patty, they didn't give me the pointer.
That's true, they didn't.
I'm not going to stand. You want to stand up and point?
I can do that.
Can I bring a pointer?
Yeah, sure. If your
You
phone
can do
has a
whatever you
pointer.
like, and I'll even reinforce you for doing it. I'll reinforce the behavior.
Oh, you mean you're gonna go
version.
get one and come
Yeah.
back?
Yeah.
He knows everything.
Well, we
And
might,
his name is not Shaw.
we might continue in the meantime. See,
We're
I'm
not
not
going.
very tall, that's the problem. with
Patty,
being
just
tall.
go behind me, please.
I am, but,
So just say step 1. So
yeah, step 1, everyone can see what step 1 is.
I labeled this. I spent a month on this slide. So all animals that learn by consequences, the first step is they have to have drives. They have to get hungry. The sound is too loud. They have to escape from it. They are always the consequences. So you have to have the drive. And that's step 2 is, well, no, that changes the consequences. I think, I don't know if this makes sense. All right, I'll just go on. But so the first thing is the drive stimulus gets paired with the consequence. Now, let's say you've just eaten 5 bowls of lentils. And somebody says, oh, if you do this, I'll give you a 6th bowl. Doesn't matter, right? You're not going to eat 2 bowls, you're finished. It loses its value. So the drive, the stimuli that gets elicited by the drive disappears. So the consequence is no longer effective. Does that make sense? You feed a baby will cry. It'll stop crying after you feed them. The consequence loses its value. Thank you. Oh, here it is. So this changes the value of the consequence. Now, all of this isn't jargon, so I'm going to explain the jargon. What S is stimulus. What you see, this right here.
Point up there.
Oh, I'm sorry, I'm pointing in the wrong place. This is a reinforcing stimulus. That means the consequence is positively valued. If you present this, the behavior occurs more often. So when you're 1 year old, 1.5, you stop crying when you're hungry. What do? You say milk. Mother starts ignoring you if you don't ask with words. Got it? And so the baby learns to say the word milk, and it gets reinforced for receiving milk. Now, what causes the baby to say milk? What's the cause? Are we mindless? No. There's a brain event inside that says, hey, when I say milk, I get it. But it's an internal vent. You can see it. Have you heard of fMRI, anybody? You know, functional magnetic resonance. You can actually see a change in the brain before the action. You can see it with EEG. So even though you can't see it outside the brain, it's clearly always happening. And it elicits the response of saying milk. Again, it's a respondent action. It's a reflex. Saying the word is in response to having this thought in the brain. Now, I published this, 15 years ago. And it's a highly read article. It's in a weird journal, but it still gets read because it's what gives rise to the sense of free will. If you can reflect on that, you can say, hey, this person has a plan. Now I'm going to go back, because I'm going to go very slow today. So, right here, what we've been talking about, reflexes are here. Oh, reflexes are here. Operant conditioning is here. And reflecting on operant conditioning is stage 4. So, dogs, rats, pigeons, sparrows, all have a sense of free will. Cats, every animal up. But insects don't. But they operantly condition. Their behavior is controlled by consequences. They go back to the flower that has the nectar. But they can't reflect on it. Okay, so you understand that these are ordered, and it's just like a program. You have to do the early step before you can do the further step. Is that clear to everybody? So this is my audience, are people who understand programming, because they understand the necessity. But if you're some sort of more abstract kind of person, studies networks, you don't get it. Because they've never done, by the way, I have programmed in binary. I said that yesterday. People say, how can you do it? Well, you do it with a bunch of switches. You line up the switches, you connect them together, and that's the binary program. The switches are usually relays. And that was how the phone system worked until we had transistors. There was no programs until the 50s. None. Do you learn that in computer science? You know who invented Fortran? Have you heard of Fortran? A woman invented Fortran. No one gives her credit. She didn't get a Nobel Prize. Should have. All right, so, and here's the tree, and if you want to put in the orders here. We talked about 4 orders, but let's say this is operant conditioning. It's made out of 2 steps of respondent conditioning, and respondent conditioning is made out of automatic behavior. Reflexes exist all the way down at the bottom. If you touch a clam, it will shut its shell. It has reflexes. They don't learn very much other, but you can train only with step 2. And this is, and on the left are the 3 definitions that have to be satisfied to know what order things are. And guess what? We can tell, even for a program, how difficult the program is. We can score it. And what's the reliability of the scoring? Anybody know? 99%. So if you're trying to solve a multivariate equation and 2 unknowns, we know how many stacks that is. That's 10 stacks. So that's why there are no monkeys or chimps that can do it. Because remember, I showed you that the monkeys and chimps are down at the primary stage. A few chimps get to the concrete stage. But the abstract stage, you have variables. No animal other than humans has variables. They can recognize each other, but they can't say, oh, that woman chimp is really good looking, has a good personality. They can't do it. It's an abstraction. They can't say, oh, that woman is really smart. They can learn about an individual monkey, but they can't, or an individual chimp, but they can't learn about in general. We can tell within few minutes how smart people are in a class. It's just terrible. The smart people just show up as smart. You know, you know by the first test who works hard and who's smart. And that's what humans are about. And we can even tell, I can tell you which part of India you're from by looking at you. Okay? Everybody from every part of India looks different. The people who have lots of Persian in them look more like him. They have bushy hair that's somewhat curly, lighter skin. They have some Persian. Oh, and by the way, if you're from South India, you're more often dark. And do you know why that is? Huh?
Near the equator, sunburn.
No. Different groups immigrated to India at different times. The South Indians are the oldest group. The newest group were Persians. Right? And if you go to Nepal, you see people who have Tibetan influences. I don't see any Noirs from, no one's Nepalese here, right? I don't see anybody. It's disgusting. We already know this because of the abstract stage. And we make a big deal of it, too. It's not a smart thing to make a big deal. You have to be at stage, you have to have 11 stacks to realize it doesn't mean a damn thing. You got that? It really doesn't matter where you're from. It's how hard you work and how smart you are and how good your social skills are. No one cares really about what you look. Listen, Hawkins was in a wheelchair, right? He had an ugly mouth, he couldn't speak. We still know he was a genius. And everybody loved to read him and listen to him with his computer-generated talk. And he was clearly 14, because he changed our view of the universe. He understood understood that black holes were at the center of every galaxy and organized the galaxy and led to the formation of stars. Big, big change, right? And I come from Hollywood, and there was this guy, Hubble, who understood that the universe was expanding at an ever-increasing rate. And that's why we have the Hubble telescope. But, you know, if you don't know history, you live in a flat world. Culture evolves, and I'm telling you that being new has a tremendous advantage, because you win. I mean, everybody remembers Hubble and Einstein and Darwin. No one remembers the dean and students. It's a mean thing to say, but it's true. The only dean anybody ever remembers, see, you're too young to, anybody see the movie Animal House? No. But there's this dean called Dean Wormer, and he's the bad guy who no one ever remembers. So he's the only, if you were older and everybody saw Animal House in the 70s, you'd remember. He'd be the only dean you'd ever remember the name of. Okay, but we all know Einstein and Newton and Copernicus, you know. That's the way life is. New ideas are the ones that pay. All right, so we did this. And see, this was for my artistic friends. You can see it as a triangle. And I've covered all of this. So now we're on this step. And this is the step that Thorndike discovered in the cat box. The environment was they're in a box, and there's this pole in the middle of the box hanging from the top. And if you hit that, you got out and got to eat some food. So the environment gets paired with the thought of hitting the pole. So that's the third step. And that's what Thorndike discovered in about 1912. And then Skinner came along in 1931, and he showed that the two kinds of conditioning were different. And there were people who didn't think they were different, but they are different. It takes 4 steps of respondent conditioning to do operant conditioning. Okay, is that clear? 4 steps. So it's a program that has 4 steps. And the last one is you pair the environmental stimulus with the consequence, and that's the incentive to do the action. So that's the second. You learned 2 kinds of conditioning, you learn steps, and guess what? The next is all computer magic of the simplest sort. Why do I have to? Do you all know what a neural net is?
Yes.
So I don't have to go over that. But I want you to see, this is a neural net. And this is internal to the neural net. This is internal. And this is how we're going to symbolize them.
The thing isn't on the red. I don't know why.
I can't see it. There. So this is how we symbolize this. And I was with a guy who does network theory, Cisco-like, etc. He couldn't understand that you needed a hierarchy to solve these more difficult problems. He just didn't get it. he thought, oh, you can do it just with a line of things. But why do you, oh, that's the next slide I better show. So here's the trick. And when did this occur? I don't know. How long have I known this? Maybe 2 years. It seemed to me that respondent conditioning, pairing of stimuli, there are only 3 possibilities. It either takes, which is 0, 1. You have to have both parts. You have to have the stimulus and the response. So if you don't have either, you know you get a 0. If you have just the stimulus and you don't have the response to pair it with the eliciting a response that's already built into the organism, the pairing doesn't go. So you get a 0. If you just present the reflex without a stimulus that predicts it, you don't get it, a 0. And if you have both, you get a 1. Boy, do you understand binary? So this is the binary arithmetic. You got it? Simple as can be. And you can see that you can do a neural net instead of with all this complexity. On this side, right? You can just do it with 0s and 1s. And they have to be lined up in a series. Patty, right down, I need to have a slide showing they have to go in the right order. They have to go from step 1 to step 4. Okay, I have to show that. I didn't show that. But you understand, that's the program. So it's a really hard program. Isn't that amazing how simple it is? And you get insects. And you know, you don't want to fight bees. They're going to win. Bees will fight. And you know, if you want to stop locusts from eating your crops, they're going to win. The insects, ants. You ever try to kill ants? You kill a few, but there are always more. So don't discount how powerful insects are. They learn from consequences. They're very smart. Not as smart as mice, or rats, or pigeons. You know, you'll see birds eating away at those insects. Right? So how smart are lizards, see? So we can give a problem to a lizard and see how smart they are, which ones they get right and which ones they get wrong. So we can tell how smart a program is. And networks, neural networks, are at the insect stage. Okay? Now I'm going to go on. And here's the example, but it's up, top, down. And remember that at each step, it's linear. Okay?
It's bottom up, because it starts with step 1.
You start at bottom, well, we show it bottom 1, right?
Step
And
1 is at the bottom.
I can't see it, Patty.
Mhm.
I can't see. I can't read that slide.
That is step 4, 5. It goes from step 1 at the bottom to step 2
Okay.
to step 3.
Okay, but you notice the arrows just go up. And there's some really important stuff here. You see? And what happens here is you get feedback. And what's wrong with neural nets is the layers of neural nets, there's no feedback to them. So they don't learn from consequences. Whereas when you have stacks, which I'm going to show you next, each place in the stack has feedback to it and feedbacks to every lower step. It's not just feed forward, but it's feedback. And that makes them irreducible. You can't make a neural net act like a stack. It's impossible. And that's what this guy didn't understand. And you have to have multiple neural nets. So in the pigeon, you can teach them to pay attention to color, and you can teach them to pay attention to shape, and you can teach them to pay attention to size. And they will learn it. And they can tell which one is going on, which one leads to the reinforcement. They have the concept of brightness, shape, and color. And each are a concept. So if you get the same set of stimuli, but you change the consequences, they'll say, hey, the game is now to pay attention to color. You give this to an insect, no way. They can't do it. They don't have concepts. And that's what's wrong with neural nets. You have to have lots of them, lots of stacks. Depending on the problem, it requires so many stacks. Is that clear? So all of traditional AI is going to fail. It's going to get wiped out by this. And the hardware will get a lot simpler. And what will take the time is training. How long does it take to train humans on tasks? What?
Many years.
Many years. Try the whole lifetime. Right? We're still learning that a year and a half before we die. We're still learning. We're still getting smarter. I did a study of moral reasoning, and I took the old data and we plotted it against age, and the number of stacks that a person could deal with was proportional to log to the base 2 of age. We go up by 1 stage in adulthood. That's like moving from knowing what the hell the properties of systems are to not knowing. Properties are 13, 1.5% of the population. And life is unfair. You know, we live in evolution. The smart people get all the coins. The R is 0.7. With how many stacks you have and how many coins you get. It's very unfair. And we did this in 3 cultures. Then culture doesn't matter. What matters is stacks that you can deal with. And opportunity for training. That's what education is. You don't get smarter going to school. You can apply the smarts you have to more problems. That's it. And that's simple. Let me keep going. And I gave you this, I passed around the, who has it right now? The USB drive. There are some newcomers that can copy onto their computer these talks. These talks are too dense for you to try to remember from listening. Too many ideas, 3. You copy it now. You got to pass it on. You have a computer? Do it. You just hit 0, 0, 1. You have your computer? She answered the first question yesterday. Weren't you the one who answered? You did, not you, but the woman behind you. Yeah. See, I have a tremendous memory for place and sequence. And all my theories come out of that. And that's why people aren't as smart as I am, because I can remember everything. I remember you. Now, I don't remember anybody's name. I have dyslexia. I misspelled my name in the 5th grade regularly. I have pretty severe dyslexia. Okay, so you're going to have this. I don't have to go on. So I just said this, each node will be respondently conditioned. So you have a very different architecture for the neural net. It's just in a line up, one line up, right? Now, and I went over this, the 4 steps. And here they are spelled out so you can learn them. They're much clearer here than when I did it before. And I did tell you about stacking. But here's the case of a stacked neural net. And look at how different this is in deep learning. Or any kind of learning, modular learning. And the things that people don't understand, they don't understand you need multiple neural nets. Each one of these, each box is a neural net. And why do you think our brains are so big? Because we have to process each pixel after the retina, right? It doesn't just pop into our brain. It has to be processed by a neural network. And then those neural nets have to be combined. You know, there are a lot of animals that can only see movement. They can't look at a static picture. We're pretty dumb. We can't see ultraviolet. We can't see electrical fields like sharks. We can't see infrared like snakes. So we don't need all of it. We have a terrible sense of smell. That's why we have to use dogs to look for the drugs. So it's not just how many senses you have, but it helps. And androids will have all the sensors. So, you know, they cost a lot to process sensors. That's why we don't have them all. And we're not strong. There's no one here that can beat. I think even a chimp will defeat everybody in this room, the whole room at once. We just can't kill, you know, by hand we can't kill chimps, but they can kill us. So it's not about strength or the number of sensors, it's about the number of stacks. And that's our only advantage. Stacks, 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 stacks. So notice I only gave examples of 3 sets of stack 1. And they get combined into stack 2, and then there's a stack above that, and you already saw that. And notice how complicated the feedback is. So even though you're going to have a very simple processor, the hard thing is to build in the feedback. So you're going to make the processor look like this picture. And each neural net will have the 4 or 5 steps, but there'll be feedback from the higher, this is, this is the part that's missing from here to here in a neural net. So we have the architecture. You see why this is a talk about hardware? And do you think I'm never going to build this thing? No. I don't care. I'll make money. I patented it. I don't have to make it. That's for you guys. One of you guys will say, hey, this nutcase Commons from Harvard came and told us how to make $1 billion trillion. And some of the chances that, how many people are in the room? 30? 20? 25? 20? What, 25? Huh?
20.
20. The chances there could be one person in the room. Okay? But most of you will become deans. It's terrible. See how nasty I am? I am nasty. Okay, so here it is again. This is the one that has the data. You have a teeter-totter. You know what teeter-totter is? And the kids get on it, and when they're 4 years old, they have to fool around. They can't figure out how to get it to go back up and down. The heavier kid is too far away. You know, they can't calculate it. When can they calculate it? At the primary stage. They can figure out by experience. They have to memorize it. Oh, I remember that one. That woman was heavier than that other woman, and so when they got on the teeter-totter, they had to sit closer. But they only learned it by experience. To understand it, that you have to multiply the distance from the fulcrum times the weight. That's the same as the distributivity problem, right? Weight times distance. And we did it, and we gave simpler neural nets, they all failed. They couldn't learn it, ever. Do I have the data, you think? No. But I have that in the slide, the talk I just passed around, the Android's talk. So you'll see the actual simulations. So I work with people who could do things I can't do, but I have to tell them what needs to be done. You're all smart enough. How many people know about hardware in here? Any of you know about hardware? Do you know about how transistors, how integrated circuits are made?
No, we have learned the basic of it, but not at much that depth.
Anybody here learning the physical part? You'll know somebody who does, right? And remember, the boss is the person who collects the money. You just have to convince them of what's worth doing. I mean, that's why Steve Jobs was a multi-billionaire, and Bezos is almost a trillionaire, you know. You think they do the work? No. They just say, hey, you want to do this? They don't tell them to do it. They say, hey, do you want to do it? This, you know, you have an idea, come to me. I'll give you some money. And there will be no dean telling you what to do. You are in charge of your own project. Google's the same organization. Universities, who has the power? The professors, not the deans, not the president. You know what the president of Harvard does? Raises money for Harvard. The guy who sits over here in that office, you know the guy, the dean? You know him? What does he do? Raises money. So you guys get this roof, this building, right? Is that clear? So you have to learn. The hard part for engineers is to learn to manage people. That's the hard part. Tomorrow I'm giving out tests, but I'm not giving the one on problem solving. I'm giving the one on understanding other people and interest. We're gonna see how well you're matched to jobs of various sorts and how well you're matched to each other. See, how many generations of people are there in India that don't have arranged marriages? How many? Come on, somebody knows this. Did your parents have arranged marriages? Yes. Anybody here have parents with romantic? One. And he's from the north. Are you from the north? See, I can tell. Okay. Did your parents have arranged marriage? Yeah. None of you are going to have arranged marriages. But you don't know how to pick partners. And tomorrow I'm going to teach you how. And I'm going to teach you which jobs you should be looking for. So you see, I can do all of this. I can do economics, political science, I can do all of it. It's all the same. Why is it the same? Because it only matters about stats. And the higher, I'm going to go all the way back to the beginning. Half the people are between these two, abstract and formal. Half the people in the world. The abstract people are the clerks, the file clerks, the typists, the data entry people, and the people at the formal stage know whether, let's not assume that you pay people off, but let's say you're trying to get a driver's license, you have a driver's test. They're the ones who could tell you whether you passed the driving test without a bribe. Okay? They understand cause and effect and whether it's met. And the people above it can tell you whether you could ever be a race car driver. How many people know about Force India? Okay, so that's a pretty important thing to be able to tell whether somebody is good at taking risks, has fast reaction times, multivariate. How many variables do you think there are in race car drivers? Ever met a dumb race car driver? Never. They're all extremely smart. And they have to be able to I'm going to use an animal term, fox the other drivers. And they have to have good reflexes. They have to have they have to be athletes, right? They have to be strong. Are they real tall? Are race car drivers real tall? No. Why? Reflexes too slow. But they're thin. Every pound counts in a car. They all work out. They all are strong. And Force India came in like third in an F1 race recently. It was a magic. You know, Mercedes has unlimited money, right? Unlimited. But Ferrari, which is a small company, still beats it often. But matching people to jobs and matching them to each other are the most important things that you do in your life. Got it? And we know how to do it. It's just number of stacks you can handle and whether you care or not. What's back to, let's see where that is. No, it's way up here. No, it's not.
It's that table that's so hard to read with the 4 things, but I don't know.
Oh, it's step 1. Step 1, what do you care about? What's important to you? Most women care about having children more than men, but men like sex more than women, on the average. We're programmed that way. That's genetic. We don't have, you know, there's a lot of variability and overlap. It's nowhere near 0.6 or 7. I mean, you find men who like to teach elementary school, but most women are the teachers in elementary school, aren't they? Even in India. And high school, the number of male teachers increases. Harvard Medical School, most of the students are women now. They love caring for people. You got it? So we understand how to measure step 1. And we combine it with stacks. We do about 0.7 R of predicting how it's going to do. And tomorrow, if you come, you can take these tests and we'll send you the results. And you can get whoever you're going out with or married to and see whether it's going to work out. It predicts it long term. We did a study where we looked at women who married athletes when they were 19. Because they wanted good-looking, strong guys, you know, sexy. 30 divorced. They're smarter than their husbands. They got tired of having an adolescent around the house. What changed in our culture? We men, all of a sudden, really liked smart women. Was not true until the 90s. It was the women's movement in the United States that spread around the world. Got it? Now, who wants to go out with a dumb woman? You're going to have dumb kids. Who wants dumb kids? I never met anybody. But they didn't understand genetics. And women weren't good at teaching it, but now they're good. What?
I thought I had a question about the different ways of creating neural nets that are in this paper.
There's just really one.
Well,
I mean, the picture of what the neural net is going to look like.
That was sort of my question then.
Well, here. I mean, here's the stack. So stacking is more than the 0, 1.
Stacking is higher.
Yeah,
I think that's the one piece that's missing.
But here's the picture of the respondently based neural net. So you just have to have more of these. they're just one box, each one of these.
Is this
just
the
one box.
bottom? I mean, if you had to create a neural net all the way from automatic,
No, you're talking about stacking. Don't confuse the neural net with the stack. They're different. The stack organizes neural nets.
so this.
The neural net itself, this is the neural net itself.
Okay. I might not be the only one who didn't get that.
Well, did everybody get the idea? Neural nets are different from stacks.
So when you showed the box and with the circle inside it,
Yeah, that's a neural net.
that's a neural net, and this is what's in the box. And then what you take is you take each of those
Right.
boxes and
Right.
you stack
The
them.
organize. Yes.
So every box is a different neural network.
So Patty, I got.
Yes,
that
every
here.
box is a different neural network
And you know how many we have?
of this kind.
You know how many we have? Close to 1 billion.
As a human.
Yes. And we, in fact, know that people who solve more difficult problems have different architecture in the brain and have more neural nets built in. Yesterday I talked about the Nepalese study where we took non-literates, never been to school, had no reading, no writing, no arithmetic, a little bit of counting. Everybody can count, but not high, but a few numbers. And when we trained them up to doing the test, they looked just like us. It's built in. And that's why society is terribly unfair. We know that the number of stacks you can deal with predicts your income, predicts your success. But there are a lot of problems that even very smart people don't know how to solve. They don't know how to solve the relationship problems. So billionaires, it cost Jeff Bezos $500 billion to get divorced. You know, from my culture, we would have worked with them to work it out. If you're French, we'd say, okay, we'll do a little sharing. You know, and we'll live with it. I mean, there are better solutions than divorce, but they weren't well matched in the beginning. Did Steve Jobs ever get divorced? Never. But the guy who founded Google, he got divorced, but he works with his wife and he's very good friends with her. She's the one who runs 23andMe. Okay, so these outcomes have to do with matching. Was she interested? She was interested more in genetics and its general effects, and he was interested in search and having the place on the search engine determined by the consequences, how many people clicked on it. Operant conditioning. He says it, we read about it. He says he used operant conditioning to develop Google. All right, more questions, we have lots of time. I didn't have to go fast. No one has any questions or comments? Yeah, you can ask. Oh, did you raise your hand or you just were wiggling?
So, when we talked about the Android in particular, how many neural nets we are talking about? How many stacks or neural nets we are talking about?
I'll go back to this. I can tell you. I can tell you by percentages of the people that show this. This is like 5% of the I could not be a race car driver because I can't find the controls. 5% of the people are here and below.
As adults.
Huh?
As adults,
As that.
okay.
I
They're-
think this is
they're-
around 30% This is about the same, 30. This is 20%. All you people are there or higher. Okay? 1.5%. Research scientists, big universities, research universities, all are at that stage. They all understand properties and systems. And what's interesting is high stage people understand low stage people, but not the reverse. And that's why the women get so mad at the adolescent men, because the adolescent men are down at these two stages. This is late adolescence. And they drive these women who are professionals, you know, here, crazy. The men don't understand the women, and it drives the women crazy. And that's why arranged marriages, the adults have better judgment about how smart the men and women are than the men and the women do when they're in early adulthood. That's why it works not so terrible. But romantic marriage is really in trouble. 50% divorce rate.
So, but his question, now that you've clarified the
Oh,
proportions
I
of
didn't do
humans.
this one. 0.06%. This you can count. There are 1,500 people in the world at this stage. Okay? And if you look at their brains, they're different. Einstein had a big bump in the visualization area. He saw pictures. And he could go back and forth between pictures and symbols. What's the hardest part of calculus? The 3D calculus, right? Picturing things really is expensive in the brain. Really, really expensive. So why are race car drivers so unhappy? They love what they do, by the way. They're addicted to it. And if you notice, they make very good commentators. They do reflect on what they're doing. Yes?
But
Wait, he's next and then you. Go ahead.
How can one reach from one stage to the next stage?
How can you do it? Well, we don't know how to rewire people yet. We will.
By training, I mean.
Well, there'll be genetic engineering will be able to do it, but you can't. You can train people on a test they already have the brains for, but you can't grow the brain. And that's why age is so predictive, because the brain is growing. Even in adulthood, the brain is changing. You get rid of the noise in adulthood. You can really. Why is it that runners, long-distance runners, are so old? They're not the strongest, but they're the smartest, right? 39. The long-distance runners in their late 30s. You'd think that running a race wouldn't be an intellectual smartest task, but it's totally that. It's basically like race car driving. You have to know how fast to go at what time, when to pass, where you should be in the pack, out front. You have to reserve so that you can. One of the things you learn really early on in long distance running is you you have to save up for the end, because it doesn't matter once you're done. But if you go too fast, too early, you're worn out. So it's an intellectual task. Takes smarts. You can't grow the brain, but you can. You see, I understand sports, social behavior. I'm high up there. And what you are doing each time you change the stack is you're integrating all the earlier forms of smarts. You're putting them together. When I do algebra, it doesn't matter that I took algebra 55 years ago or 60 years ago. I can do it still. I have to practice a little bit, but I can do it. I can do calculus, I can do probability. If you ask me to program in binary, I can still do it. But I know I wouldn't do it. I would use modular. I would use already written programs and combine them. That's what you guys are taught to do. You have subroutines that you pack together and make bigger programs, much more efficient. And that's what Smarts is doing. Smarts is taking subroutines and making them into routines. But what the content is different. I see everything abstractly. I don't care what the field is. If you give me a problem for any field, I was talking to this guy who does painting restoration. He was surprised that I knew all about it. And I even knew what his personality was like. Because I know what it takes to be a paint restorer. Is that clear? You can't grow it. You can learn to apply it in a new area, a new set of tasks. Most people who are computer scientists would make good doctors if they could have the patience to pay attention to people. They make more money. Doctors, in the United States average about $200,000 a year. And guess who the doctors are at Harvard? Where are they from? India. They all come in, the ones that don't care about money and like to fool around with puzzles, they become the engineers in Silicon Valley. The ones that want to get rich become doctors or businessmen. But it's built in. I don't even know that you could change your interests. That might be built into the R is 0.5. The heritability of interests. You're next. Come on. I don't have the button on you. Now, do I have the button on you? No. There, now I've got the target. Here, if I put it here, you're an Indian with the red dot in the middle. What does that red dot mean anyway? I never found that out. What does it mean, the red dot in the middle of the forehead?
Indicates your marital status?
No.
It's
Oh.
just something religious.
Something religious.
I see. Oh, that's the other thing. More and more students are becoming irreligious. They don't believe in magic. It's true. And you think you think your grandparents are happy about that? No. They're not happy. Right? So I'm telling you, progress is inevitable. It's just when you want to get on the train. India's going to have fast trains. We know that. China has them, but India... I love watching the people get on the top of the train. I'm wondering how they get through the tunnels. They lie down. You have to remember you come from a great country and very adaptive people, but stuck with all the craziness. More nonsense in India even than China. China is pretty high in nonsense. And the United States, forget it. We don't even believe in evolution. I mean, you know, and we look at our president, mentally disabled. Just shows you we can have a handicapped president. I mean, it's crazy. Don't, you know, democracy works most of the time, but not all the time. Go ahead. You had something. Sir, with the white shirt. Nothing? How about you in the back? You don't have anything to say? None of you. I hate it when the women don't talk up. It makes me angry.
Well, that's really going to raise the probability that they'll talk.
No, she has questions. She just is shy. Do you have any questions?
I had a question. I think
Yeah.
it's a silly question. I wanted to know how do you know that this person belongs to this state? Like, how do you decide that?
Repeat the question, Patty.
How do you know that this person belongs to?
This stage.
Yes.
Oh, it's very simple. It's, you know, there's a whole group of people who test programs out. They see when they crash. It's a very interesting part of computer science because all programs crash. And to find out where they crash, and we crash. So you just see where the people crash on a task. So if I give you a task of figuring out why personality and smarts are different, you would have a hard time doing it. And so when you read personality tests, well, you make up tests for smartness. They don't predict well. They have 0.7. Stage, these things predict 0.98. So they worked on smarts, you know, since 1908. They just never understood what they were measuring. They didn't have the right variables. So you have to know what task, the difficulty of the task, give it to a person. They either can get it or not with training. You're smart because you asked the right question. The question tells you the answer.
See, but there is, every task the person could be different on. That's also.
No, but that's generally not true. The correlation between tasks is 0.9. So if you're good, people say, well, what do you do about engineers and they're lousy at relationships? I say you train them. Then they get good at relationships. But you have to speak engineering. You say, you know, friction causes heat. So you don't want to be fighting all the time. But if you speak engineering to engineers, you've improved their relationships as fast as possible. They can do it, they just weren't interested in doing it. You understand? So I was telling people, engineers are great to do therapy with. They're all in the top 20%. They all understand we're in this together. And they can't sit and blame the other person all day long. That's like saying the computer program stinks. Everybody everybody knows that programs take a lot of work to clean up. And that's what relationships take. You have to find out, what are the things that are impossible for other people to do. And you have to respect the differences. You can't believe in free will. You can't think that the other person is your enemy. And you have to remember, we all have problems. Everybody has problems. I can't add, I can't subtract. I'm okay at multiplication if I don't have to carry. But I'm great at estimating. I can tell you what's a good investment. I can read people. I could tell he was from the north. And I'm reading a lot of things to make the judgment, not just one. But you have to train people. And most therapists in psychology are not trained properly. They think it's all magic. And they ask you stupid questions. And they think that your childhood determines your adulthood. Now, this is what determines your adulthood, going to this school. And learning that it's either for you or not. It has nothing to do with your parents. You're so different from your grandparents, so it can't be the environment. It's got to be built in. And interests are largely built in. So what's reinforcing? You don't choose what you like. You really don't. Think about, are there any of you who don't like the certain Indian spices? Any of you don't like, do you like all Indian food? No. Did you choose that? No. What food you like is built into you. You might not have tried it, so what you said, you might have to try it. It's not going to change your brain. Learning is different from capacity. And I'm saying that the capacity of neural nets is that of insects. We got to get the capacity up. Okay? In deep learning, not enough modules to handle all the information we have to process. Do you know that when I used to go to Mexico, people stunk? Everybody here uses deodorant. Whole world changes just like that. So who controls whether the men stink or not? The women. They don't like it. They don't like stinky men. I don't know why. That's for you to figure out. I don't know. It seems to be built in, but I don't know where. I can tell you that people who smell a lot aren't healthy. They don't clean enough. How long are you going to live? Who's going to live the longest? How old is your grandfather? Sir, your grandfather, how old is he?
60.
60.
65.
Who has a grandfather over 80? You do. You do. Okay, so we know you're going to live longer. You're going to live into your 90s. He's in very good physical shape. He can go a long ways. Right? You can run for miles. Right? How many K can you run?
easily run a 10K also.
He doesn't.
10K or so.
10.
10K, yeah. And so he has the longest life expectancy. That's one thing you can change. It's behavior. And if you run on dirt, your knees won't give out and your back. If you run on pavement or stones, you'll wear out your back. Only 20% don't wear out. It's completely inherited who wears out and who doesn't. So your question is the right question. How do you determine what's going to happen? You have to test people out on the task. And I gave you 20 or 30 tasks in this talk. I came up with one that I thought was clever. Last year? Yeah, it was in England. I figured out that we don't have enough stacks, ever, no matter what we do, whether we make machines or not, to figure out what the real questions are. We're too limited in stacks. The problems are more difficult than the people or the machines. So we're stuck at being closer to worms than gods. And that should make everybody take care of other people because we are closer to worms. We die, we learn, we eat, we defecate. We're closer to worms than gods. There's no perfection in human beings. None. Yes?
You said that training would take a longer period of time. And when we earlier talked about Android, you said that learning would be faster. So learning is just an education for Android? That's what
You just present tasks at the next stage. Goes back to your question. And then you reinforce solving those problems. One stage up, 2 doesn't work. Because you can't coordinate what doesn't exist. You can't organize it. But you have to present the tasks and reinforce. And for humans, with genetic engineering, it'll speed up. But before it, it's fixed. And the formula I told you is log to the base 2 of age. That tells you how fast you learn and how smart you can get. And there's a constant there, it's proportional. So if you look at nursery school children, you can tell how smart they are. Not in infants, but nursery school. By nursery school, testing for primary stage tasks, like doing arithmetic and reading, will tell you. And guess who learns to read first, women or men? Women. They're better at languages. It's built in. Their brain organization is different. Men have trouble understanding relationships. And women are very, she knows 5 languages, I know half of one. I have dyslexia. I can't even spell the name of the city. I can't say it. But I'm smart. I have a lot of stacks, just not in that area. And that should answer your question also, It's biology. And if it's biology, you can't be mean to people who don't have the biology. It doesn't make any sense, because you don't choose your parents, or your genes, or where you're born. None of it. So blaming people for who they are just makes no sense whatsoever. That's why we love making machines to help people. We love our toys. Toys are fun, and engineering is just playing with toys. And that's why there are more men in it than women, because men like manipulative toys more than women. We know that, right? That doesn't mean that there aren't a lot of women. I told you the woman who invented programming, modern programming, Fortran, was a woman. You know, the person who figured out what DNA looked like was a woman. In the sport I do, orienteering, women are as good as men. They're not as fast, but men are stronger. They have more muscle in their thighs and in their calves. But the women don't get lost any more than the men. And to answer your question, if you're doing a race where you have to find things in the woods, the best performers make mistakes. Everybody makes mistakes. That's why no one writes the perfect program. And why did Microsoft not divide memory from computation until Windows 10? Insanity, right? So if you had a memory, a programming problem, it would overwrite all the memory and it'd crash. So we're dogged with problems. And I think engineering helps people tremendously. And I think it's pro-social. And I think more women will do it because it really solves problems, whereas psychiatrists don't. And you know, when you go to the doctor, only 20% of the time can they help you. You get the flu, forget it. They don't do anything for you. You have heart disease, they can replace your arteries, right? They're mechanics and chemists. Applied chemistry and applied mechanics, but everybody reveres them. They're magicians. They're not. I work at a medical school. Actually, engineers are smarter. And do you want to know why? Because engineers hate when the programs crash. And you know whose fault it is. You don't blame the user of the program. You know why the program is crashing, because there are errors in the programming. The things that you haven't taken into consideration. Now, at what stage do you understand that all programs crash? What stage do you have to be at? 12 or 13? Which is it? 13. But you're close enough to 13 that you know that all programs crash. You know that. So you already know that there's no solution to any problem that's perfect. Yes?
How do we introduce classical conditioning in neural networks?
You build the neural networks the way I said, switches that compute products 0 and 1.
Yeah.
And you know how to build a switch that you put two switches together, right? The first switch says, did the second part of the reflex occur? And the first switch says, did the first one occur? And they both have to be positive to go. It's trivial.
So how
And do you know how a switch is made in hardware? You know, you know that a transistor is just a switch, right? So that's it.
So how does it differ from the reward conditioning that we currently use for reinforcement learning?
Well, the difference, first of all, is it's fast. Are switches faster than analog? Amplifier is much faster, right? In fact, took years of transistors to get up to speed that switches could be at. I mean, you know, amplifiers used to fail at 20K, 20,000 hertz. And there were switches that would go to 100,000 hertz. So it's fast. Got it? And hooking them together is really fast. Yeah, isn't it? So that's how did I answer your question? And they just have to be, you know, and you know that transistors are going to be 3D. They're now flat, but they'll be 3D. Because why is the brain 3D? It has to be 3D. You can't get enough switches in there. And you know, a neuron is just a switch. I mean, what Jay McClelland and Stephen Grossberg told me is they used operant conditioning as the model for making neural nets. And I'm just saying you can do it faster by using switches rather than weighting nodes. Okay? Making analog calculations is slow and you don't need them. And remember, memory in computing is all switches. We don't know how to make analog memory, do we? So you might as well get down to the basics this morning. And have stacks, which is not thought of by neural network people. And we know we need a lot of them. And so it's much easier to make a series of switches than a bunch of analog computers. You know, it's multiplying the two things, the cause of the reflex and the thing that causes the built-in reflex, really, really simple. And you can pack them very tightly together. You probably can do better than meters because the noise is so low. And what do you think a lot of the brain is made of? Insulators. The myelin around the nerves to keep there from being crosstalk. So we know what the problems are in the neurons. And we know that you have to go 3D because these stacks you probably want to make them in layers. You know, in literal stacks. You probably want to imitate, I'm answering your question, but at a higher stage. You probably want the architecture to emulate the stacks. And you surely want, but we know that the cross connections are what takes up the space. I'm going to go to this diagram. Here we go. You see all these interconnections. You see that these outputs have to be collected. Let me go to the 3D one. Wait, I'm not pointing. Just let me go.
there, it's a little further along.
There. See, you'll notice how many interconnections there are. So there are going to be many more interconnections. And what are the, in real life, what are the interconnections made of? Axions, right? The receptors are the dendrites. So you're going to have the same structure. You don't think that a billion years of evolution didn't get it right. Right? It did. So we don't have to invent it, we just have to do it. Got it? And remember, each sensor is what the inputs are changed in each stack. They look like the output of the stack, not like the input of the stack. And that's what the guys don't understand in neural nets. It's transformative. The outputs don't look like the inputs. And the human brain, they look the same. That's why it takes even more neurons than what I'm proposing. Yes?
Can I map a set of problems to the stages?
Patty?
Can they map what problems?
A set of problems, a group of problems, to a particular stage.
Yes, of course, that's her, what did she say? That's her question. We can always find out what the stage that the number of stacks will do.
Does it have anything related to computation, complexity theory? Complexity theory, is it mathematics? NP hard problems kind of?
I just learned about NP, but I don't remember it. I forgot it already. It was yesterday, so didn't stick. Tell me what NP means.
So basically, there are some set of problems that have a level of hardness in it.
Yeah.
Yeah. So, for example, there is a let us say that you know that a solution exists, but it takes a lot of time to get to that solution. That is a some, I don't know the level.
In the talk that I sent around, I answered that question specifically. I give you actual numbers in the simulation. The more stacks you have, the faster it goes. So the NP answer is the more stacks, the faster. I can solve problems. People ask me, why don't work hard? I said, because it takes me about 5 seconds to solve a problem that takes people 10 years. I'm smarter than most people because of what she said. I can do more difficult tasks. I didn't choose to be that way. I'm born that way. But I can't add, I can't count, I don't recognize faces too well. You know, I got a lot of problems. But I am smart. And I solve problems really fast that other people struggle with. Why didn't some other neural network person come up with this? I don't know. To me, it was trivial.
But you said that a higher stage person can easily understand the lower stage person's problem.
Yes.
So,
I understand that they're not smart enough to do this, and I can tell you why.
but then you should be much easily able to do addition, subtraction, and say you cannot do counting than the other people.
No,
I mean,
I'm not good at that task. That task is directing attention. And I'm not good at directing attention. I would make a terrible race car driver.
But that is an easier task than a harder one. So, theoretically,
I can do all arithmetic, but I'm not accurate. That's all. It's not that I can't do it, it's just that I'm not accurate. I get lost. Okay, now I want to show you, I'm already lost. I think I want to be here. What Sophia, my colleague, showed was at what formal plus 2 is, formal minus 2 is concrete. I have to think. See, I'm bad at arithmetic, especially subtraction. I failed subtraction in the 3rd grade. I had to go to summer school. So, at the concrete stage, if you only have 6 stacks, you can't solve the balance beam problem, the teeter-totter problem, ever. You can never do it. Okay? How fast do you think I can solve the teeter-totter problem? Much faster than even somebody at the concrete stage, because they have to think about it. To me, I can look at the teeter-totter, I can tell you, I can line up everybody in this class and tell you where they should be on the teeter-totter. I don't have to do any calculating. I can just tell you, because I can tell you everybody's weight in this classroom. He's the thinnest person. He weighs about 135. I don't know it in kg.
Pounds, yeah.
Huh? I know it in pounds. Divide by 2.2. He's the thinnest. I think you're the heaviest. And you weigh almost twice as much as he does. Am I right? I'm not talking about nasty. I'm talking just, it's not about choice. And she is in the middle. And she's the shortest in the class. So I can tell all these things. And so the calculations, when you're very smart, go very fast. Even simple things get faster. So back in, I think, the early, mid-'80s, what I realized was you don't even think about the lower stage things, because there are faster ways to solve the problems. I was trying to predict things about crime. How many people did crime, how many crimes a person did, and how serious the crimes. Do you know how big the field of criminology and sociology is? It's a huge field, right? There are all these people. They can't predict either of those things with R's of about 0.5. I did one study with a Chinese student. We predicted the number of crimes with an R of 0.9, and we predict seriousness of crime with an R of 0.99, because I said you had to have the right variables, and you had to multiply them, not add them. Why didn't the criminologists know this? They get paid huge bucks, the FBI, Look at all these nincompoops driving around, these police. They don't know any of this. And they paid them big bucks. But I'm smarter, so to me it was obvious you had to take the product of impulsivity and anger, and you take the product of that, and you're going to get most of the variability.
If they take the same thing as an input, they cannot, is it more about the perception than about the smartness?
Patty, I can't.
Is
hear.
it about what?
It is more about the perception or how we perceive a problem than the smartness.
Well, how you perceive
No,
the
it's not.
problem.
It's not it's about smartness. When we give tests of IQ, it turns out the first factor is stage, and it accounts for an R of 0.9. And the next thing is how rare the problem is, like the words or the pictures. That's 0.5. I mean, things are a lot simpler is what I'm saying. People get lost because they don't know how to write the equations. The equations, were the equations here hard? I showed you. They were just incredibly simple. These equations, how trivial can you get? 3 conditions. 3. You don't need a book, you need this figure. It's not complicated. And everybody knows what these mean. Everybody knows what defining something in terms of something else is. And we all know what organizing means. And we all know what non-arbitrary means. It's not difficult. But they could never make that into this tree. And they didn't understand that everything is organized in this tree. Get it? It's very, and to me, this is simple arithmetic, right? You ask a 4th grader, they can understand the tree. You can ask somebody in junior high or middle school about these conditions. They know what defined in terms of other things. They know what that means. They know what organization means. They can't put the 2 together, but they know what each mean. You see how I'm doing the task analysis? So that's how you judge the stage. You do the task analysis, see whether people can do it. I mean, it took me time to work out what stage insects were at. But the hard stage, this stage, sensory or motor, is only 4 years old. That was really hard to come up with because you don't see many animals like that. And most animals move about, and therefore they're controlled by consequences. You should write that down. I never ever said that. It's the moving around. So you will find very low animals that only are automatic. The ones that make the reefs. What are those called? I forget. See,
Corals.
Corals. The things that make the corals. They don't move. They're filter feeders. Filter feeders are automatic stage. But the ones in between, we know very little about. I thought maybe squid, but no, squid are already learned from consequences. So it's the in-between one that only learn from pairing of stimuli that are hard to find. Because once you get one of them, the chance of getting all 4 steps are really high. That's my guess. I mean, if you can get the respondent pairing conditioning to work, why not do it 4 times for the different parts? I mean, even the muscles and the clams are sensitive to the consequences but they're all reflexes. And they are sensitive to light, but they don't have brains. You know there are no brains in clams. Did you know that? They lose their brains. They used to have them when they were swimming around, and then they gave up their brains when they attach. They don't need them. Listen, evolution is the only thing that's complex. Everything else is pretty damn simple. Computer program is pretty damn simple. And the fact is if you write out what you're trying to do, clearly it makes it a lot simpler. Most people they don't know how to break down. They don't know how to reverse the problem. They start at the beginning and try to get to the end. I always start at the end and try to go to the beginning. It's a lot easier. Did they teach you that in programming? To start at the end. They teach you that, don't they? Right? They teach you that in programming. It should be, the first year they should teach you that. You know that? To start at the end of the program? Pretty much know. Everybody knows that. You can't build the program from the beginning. You waste all your time. You don't know you don't know what you need. And I'm saying that's the same question you asked. What do you need? And you figure out, if you can figure it out what they need, then you can know how smart people are. So, is Trump good at talking to people? Very good, right? But he can't solve any problem that involves the real world. But he's good at talking. He's a good entertainer. Could I ever train him? I think he has too many disabilities to train him. I think he really has disabilities. A friend of mine's writing a book on it, but I have to write a chapter because he doesn't know. He really doesn't know what he's talking about. But one chapter would straighten it all up. The guy doesn't have any inhibition. He just blurts out whatever he has to say, which is what I do. But I at least am in the control of real consequences. My businesses don't go bankrupt all the time, and I don't have a daddy to save me. And, the reviewers of the publications say yes or no. So, what? We're just almost there. We're there. We lost a few people, very few. And these guys are enjoying it. There are even people came back for more. Did I get my USB drive back?
It's back on the table back there.
Did everybody get to use it who wanted to? But I record these because I never write as well as I talk. My talking is always better. And I need you guys. I need all of you. You all ask good questions. I would never have thought of those questions. Do you see what is a social network? Now, who didn't talk? Just you and him. Everybody else talked. Do you have a question? An answer? How about you? Okay, so I did pretty well. There are 1, 2, 3, 4, 5, 6, 7, 8 of you. I got 75% response rate. I've got to get it up to 90. All right. Anybody have anything else to say? Are any gonna come back tomorrow to take these tests? You can bring your lovers or your boyfriends or your girlfriends. I'm gonna get your email addresses and send you the results, and then they'll wanna know what they are. Because once the women get hold of this, it's the women who control reproduction. Just remember that they have the real power. The men think they have the power, but women have all the power. They choose the men. And who are the arrangers of marriages and families? Do the men do it or the women do it? The women do it, right? We know who has the real power, so get used to it. All right. Thanks. What kind of bike do you have? What kind of motorcycle?
It's a moped.
Moped. What brand? See, I have Hondas too.